The Lorax was written in 1971 by Dr. Zeus. Its underlying theme is about the damage that consumption and business can do to our environment. The Lorax tells the story of an entrepreneur, the Onceler, his new product that everyone needs, the consumption of natural resources to make this product, and the detrimental effects on the natural environment. A quote from the Lorax states, "Unless someone like you cares a whole awful lot, nothing is going to get better." We believe that this book presents the idea of sustainability in a gentle and fun way, allowing us to open discussion about more difficult topics with students. The images that inspired our model were the Super Axe Hacker and the Thneed Factory.
The two systems we integrated into this model are pneumatics, cams, and levers. Pneumatic systems use the energy stored in compressed air to move parts. By controlling the release of the air through syringes, we can turn that energy into movement. Levers are a simple mechanism which helps to reduce our efforts when applying force. Several levers can be connected as a linkage to move several parts at once. In a mechanical linkage, a cam is a rotating or sliding component that is specifically employed to convert rotary motion into linear motion. It frequently refers to a portion of a revolving wheel or shaft that at one or more places along its circular course connects a lever. The first system incorporates pneumatics using syringes and compressed air. This then intertwines with the second system, affecting the movement of the cam and skewer, that then moves the axe and cloud feature on the model.
By the end of Year 4, students should be able to identify how materials are used and how movement is created. Using this model, students will observe movement and force and energy created by the systems and describe them. Using the model and engaging with the systems will help students describe how forces and their properties of materials affect a product or system. The cross-curricular links involved in our model are design and technologies and sustainability. A lesson on design and technology and sustainability encourages students to examine design and technologies and judge how sustainable they are by their impact on our environment. We would be able to use the model as a provocation with the book set next to it for students to come and interact with. We could also have the model sitting next to us while we read the class the book. After they have read the book and engaged with the model and its systems, we would be able to discuss sustainability and design technologies. First, we investigated the chosen storybook and decided on what scenes and themes we would like to incorporate into our model. Next, we designed some drawings that allowed us to plan what the model would look like and where our features would go. A separate drawing was done to show how systems would work together and where they would go. During the production stage, communication was crucial as we did not have time to meet outside of class time. It was important that we stayed organised and up to date on delegated tasks. Communicating allowed us to manage the project and make progress. The materials needed to create the design were wood, a power saw, wood glue, nails, lots of different paints, paintbrushes, paper, cardboard, a skewer, drill, saw, cam, syringe, tube, cotton buds, etc.
First, print pictures of the tree and tree chopper, then glue them onto the cardboard and cut them out. Stick the cardboard features onto the skewer, then find where it sits on the back of the box. Drill a hole there for both and slide the two skewers through each hole. Then glue a drop cam onto one of the skewers. Tape a paper straw that's been cut in half on the back of the box above the cam, and then slide a skewer down the straw so that it hits the cam. Check to see if it is in place properly so that the skewer moves up and down when the cam turns. Next, attach the syringe above the skewer that is connected to another syringe by a tube. The second syringe is positioned so that the plunger sits above the top. Lastly, check to see if the parts work. As the cam pushes the skewer, it pushes the plunger of the first syringe that's positioned above, which pushes the second syringe. A limitation was that the two systems originally did not connect or work together directly. We quickly problem solved by making some drawings and altering the design slightly. Another limitation was that when nailing the wood together, the wood had some small splits. However, when the glue was dry, I applied wood filler in the cracks to maintain the structure. Lastly, using white spray paint to coat the wood required 2 to 3 layers of paint. But in the end, we were very happy with the final product and the themes that it would allow us to teach and discuss with students.